Okay, students, in the last class, we revised implicit function differentiation and inverse trigonometry differentiation. Today class, we will discuss about the logarithmic differentiation. So, in the logarithmic differentiation, you people already know the differentiation of logarithm. The differentiation of log x. What is the differentiation of log x? Is 1 by x. Is it? And differentiation of e to the power of x, the differentiation of e to the power of x is e to the power of x. So here this is a differentiation of logarithmic and exponential. The same way in the differentiation of logarithm, first you want to differentiate the log and then you want to go for the function, and then in the exponential also first you want to differentiate the exponential and then you want to go for the function in the chain rule differentiation. Now to do the differentiation of sin inverse x to the power of x with respect to x, you want to know the properties of logarithm. So we already know the properties of logarithm, so just we'll revise the properties. Log m into n. What is log m into n? Is log m plus log n. Is it? Log m by n. What is log m by n? Is log m minus log n. So this is we call it as product rule. This is the quotient rule. Now log m to the power of n is there, means you can write it as n log m. The power will come to the next to log. So this is power rule. Is it clear? Next, log m base n. This can be written as log m by log n. This is we call it as change of base rule. The last one we call it as change of base rule. So these are the logarithmic properties. So if we apply the log for the function, for the product, we can write to the addition. We are changing the product form to a addition form, quotient form to a subtraction form. This is a power rule and this is a change of base rule. Now we can't apply the log for the addition operations, means log m plus n. If the log m plus n is there, we can't write it as log m plus log n. We can't apply the log for the addition operation, and we can't apply the log for the subtraction. Log m minus n is log m minus log n. We can't write like this. So we can't apply the log for the addition and subtraction operation. We can't write like this. Is it clear? So this is about the brief discussion of the properties of logarithm. So this is a brief discussion of the properties of logarithm. Shall we solve this problem? Differentiate the sin inverse x with respect to x. So this is a given problem. Actually this problem is given homework for you people. So I am redoing this problem. Now to differentiate this type of problem, so we make use of logarithms. Why we are using the logarithm for this type of problem means, here it is a function to the power of function. The base is also a function and the power is also a function. We can't differentiate this function directly. So to differentiate this function directly, we want to apply the log. So how to do this problem? Consider y is equal to sin inverse x to the power of x. Now differentiate with respect to x. Differentiate with respect to x. So we can't differentiate this function directly. So we can't write like this, differentiate with respect to x. So what you want to do? You want to apply the log on both sides. Log y is equal to log of sin inverse x to the power of x. In the last problems, what we are doing after this, we are differentiating, but now we can't differentiate. Why we can't differentiate? It is a function to the power of function. Apply the log on both sides. We are applying the third properties of logarithm. What is the third property? Power rule. Change of base rule. The change of base rule means the power will come to the next to log. Means log y is equal to x into log of sin inverse x. Now we want to differentiate with respect to x. So now we can differentiate. Now the power is come to the next log. Here we can apply the product rule. Now differentiate with respect to x. What is the differentiation of log y? So we already discussed in the implicit. Wherever y exists, you want to write dy by dx. Means you want to differentiate the log and then you want to differentiate the y. What is the differentiation of log y is? 1 by y into dy by dx. Here you want to apply the product rule. Keep x as it is. The differentiation of log sin inverse x is 1 by sin inverse x. Again difference sin inverse x is 1 by root of 1 minus x square plus log sin inverse x as it is. Differentiation of x is 1. Now cross multiply the y. So dy by dx is equal to y into, rewrite this term, x into sin inverse x 1 by root of 1 minus x square plus log of sin inverse x. Is it clear? So this is the problem. So this problem will ask for 2 marks. So this is a guarantee question for 2 marks. Once again I am repeating, just listen here. So this is a given problem. Consider y is equal to sin inverse x to the power of x. We can't differentiate with respect to x directly. So to differentiate this problem, what we are doing, we are applying the log on both sides. So log y is equal to log of sin inverse x to the power of x. Now we are applying the third properties of logarithm. So we are changing the power to next to log. Log y is equal to x into log of sin inverse x. Differentiate with respect to x. The differentiation of log y is 1 by y into dy by dx. Keep x as it is. The differentiation of log sin inverse x is 1 by sin inverse x into 1 by root of 1 minus x square. Now keep log sin inverse x as it is. The differentiation of x is 1. Here we are applied the product rule. Now cross multiply the y. Dy by dx is equal to y into x by sin inverse x into 1 by root of 1 minus x square plus log of sin inverse x. So this is the problem. So we'll go for the next problem. Now we'll go for the next problem. The next problem is if xy is equal to e to the power of x minus 5, find the dy by dx. So this is the next problem. Now here we can't differentiate this function directly once again. So here function to the power of function is there. So what you want to do, consider this problem. Consider xy is equal to e to the power of x minus y. So this is a problem very important for your exam. This problem is asked 2 times in the exam for 2 marks. And this problem I am given homework for you people. So I am redoing this problem. So here I am applying the log on both sides. Here I am applying the power rule. So here I am applying the product rule. So log x plus log y. Here I am changing the first properties of logarithm. Here third properties of logarithm. X minus y into log e. X minus y into log e. Here the log e value is 1 here. Log e value is 1. So remember this. Log e value is 1. Now differentiate with respect to x. Here what is the differentiation of log x is 1 by x plus what is the differentiation of log y is 1 by y into dy by dx. What is the differentiation of x is 1. Differentiation of y is dy by dx. Keep the dy by dx in the left side, rest all in the right side. So 1 by y into dy by dx minus dy by dx come to the right side, it will become plus dy by dx is equal to 1 minus 1 by x. Now take a dy by dx as a common. 1 by y plus 1 into dy by dx is equal to 1 minus 1 by x. Now take an LCM. Here 1 plus y by y into dy by dx is equal to, if you take an LCM here, x minus 1 by x. X is LCM, x minus 1 by x. Cross multiply this one. This will become dy by dx is equal to y into x minus 1 by x into y plus 1. So this is the answer. Is it clear? So this is a problem. I'm given homework for you people. Just see here. Once again I'm repeating. This problem is an important for your exam. So this problem is asked 2 times in the exam. See here. To differentiate this problem, if you differentiate this problem, it will be difficult for you people. We can't differentiate. This is a function to the power of function. So we are applying the log on both sides. Log xy is equal to log of e to the power of x minus y. Here we are applying the first properties of logarithm, log x plus log y. Third property of logarithm, x minus y into log e. The log e value is 1. Now differentiate with respect to x. The differentiation of log x is 1 by x. The differentiation of log y is 1 by y into dy by dx. The differentiation of x is 1. The differentiation of y is dy by dx. Keep the dy by dx in the left side, rest all in the right side. Now dy by dx is a common. So 1 by y plus 1 into dy by dx is equal to 1 minus 1 by x. Take an LCM. 1 plus y by y into dy by dx. X minus 1 by x. Cross multiply the term, then you will get the result. So this is the answer. Differentiate the x to the power of x minus 2 to the power of sin x with respect to x. So this is the next problem. Now to solve this problem, so let me consider to solve this problem. It will be somewhat different method. So we are not done in the regular class. Now I am doing now. Now let me consider y is equal to x to the power of x minus 2 to the power of sin x. So this is a problem. Here we can't apply the log here. Why? Because if you apply the log, so log m minus n. Is there any formula for log m minus n? So log m minus n we can't write as log m minus log n. So this is already we discussed in the while discussing the properties of logarithm. We can't apply the log for the addition and subtraction operation. We can't apply the log for the addition and subtraction operation. Here since we have a subtraction operation, we can't apply the log. So what to do? Let me do like this. Let y is equal to u minus v. You want to take u as x to the power of x, v as 2 to the power of sin x. Let me separate the terms like this. U is equal to x to the power of x. Let u is equal to x to the power of x. Now let me differentiate this one. So to differentiate this one, we can't differentiate. It is a function to the power of function. Apply the log on both sides. Log u is equal to log of x to the power of x. Now apply the power rule. Log u is equal to x into log x. Is it clear? Now differentiate with respect to x. Differentiate with respect to x. What is the differentiation of log u is? The differentiation of log u is 1 by u into du by dx. Here you want to apply the product rule differentiation. X as it is, differentiation of log x is 1 by x. Log x as it is, differentiation of x is 1. X cancel. Du by dx is equal to u into 1 plus log x. U into 1 plus log x. Now what is v? V is 2 to the power of sin x. Let me differentiate the v separately. Here differentiate with respect to x. So dv by dx is equal to differentiation of 2 to the power of sin x is 2 to the power of sin x into log 2 into cos x. So this is a differentiation of dv by dx. Now again consider y is equal to u minus v. So differentiate with respect to x. So dy by dx is equal to du by dx minus dv by dx. So we already have du by dx and dv by dx. Substitute this one. So dy by dx is equal to du by dx is u is what? x to the power of x into 1 plus log x minus dv by dx is 2 to the power of sin x into log 2 into cos x. So this is the differentiation. So what I done, actually I am telling briefly now. See here, in this problem, here we can't apply the log directly. We can't apply the log for the subtraction operation. So what I done, I am taken y is equal to u minus v. U as this function, v as this function. So we are differentiated the u and v separately, and we are substituted in the at the end of the problem. See here, u is equal to x to the power of x, we are differentiated the separately, we get du by dx, and we are differentiate the v, here we get v dv by dx, and we are consider y is equal to u minus v, differentiate du by dx and dv by dx. See, we already know the du by dx substitute, we already know the dv by dx substitute, like that we done. So once again I am telling, we can't apply the log for the subtraction. Since the subtraction is operation, we can't apply the log here. So we are considered u and v, we are differentiated separately, and we are substituted at the end of the problem. Once again I am telling, just listen here, we can't apply the log here. So the case we consider y is equal to u minus v. So we are differentiating the u and v separately. U is equal to x to the power of x. Since the function to the power of function is the case, apply the log on both sides. Log u is equal to log of x to the power of x. So we are applying the third property of logarithm, x into log x, differentiate with respect to x. The differentiation of log u is 1 by u into du by dx. Here x, differentiation of log x is 1 by x. Log x into differentiation of x is 1. X cancel, du by dx is equal to u into 1 plus log x. Now here v is equal to 2 to the power of sin x. So here we can differentiate this function directly, because we are using the formula differentiation of a to the power of x. What is the differentiation of a to the power of x is a to the power of x into log a. So differentiation of 2 to the power of sin x is 2 to the power of sin x into log 2. Again differentiation of sin x is cos x. Here consider y is equal to u minus v. So differentiate with respect to x. The differentiation of u is du by dx. The differentiation of v is du by dx. Substitute the du by dx and dv by dx at the end of the problem. So this is the problem. Is it clear? Is it okay? So we'll go for the next problem. Yes. Let me go for the next problem. So log x to the power of x plus x to the power of log x. You want to differentiate this function. So to differentiate this function, we can't differentiate this function directly. So let me do this problem. Consider y is equal to log x to the power of x plus x to the power of log x. So we can't differentiate this function directly, because it is a function to the power of function. It is a function to the power of function. If you differentiate this function, we can't even to apply the log. So we can't apply the log directly here, because since the addition is an operation, we can't apply the log. Let me do like this. Y is equal to u plus v. We are taken u as this one, v as this one. Let me differentiate this function separately. What we done differentiation in the last problem, the same way we are doing. Now u is equal to log x to the power of x. We can apply the log now. Log u is equal to log of log x to the power of x. We are applying the third property of logarithm. Log u is equal to x into log of log x. Now differentiate with respect to x. The differentiation of log u is 1 by u into du by dx. Here the differentiation of log x is x into differentiation of log x is 1 by log x. Again differentiation of log x is 1 by x, plus keep log of log x as it is. The differentiation of x is 1. X cancel, cross multiply the u. Du by dx is equal to u into 1 by log x plus log of log x. So this is the du by dx. Now let me take v. Consider v. v is equal to x to the power of log x. Now apply the log on both sides. Log v is equal to log of x to the power of log x. Now we are applying the power rule. Log v is equal to log x into log x. Here log x into log x means we can write it as log x whole square. Is it clear? Now differentiate with respect to x. The differentiation of log v is 1 by v into dv by dx is equal to, what is the difference of log x whole square is? First you want to differentiate the power. 2 log x. Again difference of log x is 1 by x. So dv by dx is equal to v into 2 log x by x. Is it clear? So this is a du by dx. So this is a dv by dx. Now we know that y is equal to u plus v. Differentiate with respect to x. This will become dy by dx is equal to du by dx plus dv by dx. Is it clear? Now we have a du by dx here, substitute here. We have a dv by dx here, substitute here. So this is the end of the problem. You want to substitute du by dx and dv by dx. So this is the end of the problem. So after the completion of substitution only it will be end here. Is it clear? So substitution part you people will do. So this is a way of doing this problem. Once again I am repeating this problem, just listen here. Here this is a given problem, log x to the power of x plus x to the power of log x. We can't differentiate this problem directly. So consider y is equal to log x to the power of x plus x to the power of log x. Now we are taken separately y is equal to u plus v. We can't differentiation directly, so we are taking separate substitution. So u is equal to log x to the power of x. So we can't differentiate this function directly now also. So we are applying the log on both sides. Log u is equal to log of log x to the power of x. We are applying the third properties of logarithm. So log u is equal to x into log of log x. Differentiate with respect to x. The differentiation of log u is 1 by u into du by dx. Keep x as it is. The differentiation of log x is 1 by log x. Again difference of log x is 1 by x. Now keep the log of log x as it is. Differentiation of x is 1. Now cross multiply the u. Du by dx is equal to u into 1 by log x plus log of log x. Now let me take v is equal to x to the power of log x. So apply the log on both sides. Log v is equal to log of x to the power of log x. Log v is equal to log x into log x whole square. Now differentiate with respect to x. The differentiation of log v is 1 by v into du by dx. First you want to differentiate the power. What is the difference of power is 2 log x. Again difference of log x is 1 by x. Cross multiply the v. So dv by dx is equal to v into 2 log x by x. Now we know that y is equal to u plus v. So let me differentiate with respect to x. So dy by dx is equal to du by dx plus dv by dx. Du by dx by dv by dx. So we know the du by dx, substitute the du by dx. We know the dv by dx, substitute the du by dx. This is the final answer. You want to differentiate this problem like this. Is it clear? So actually it is a very easy problem. So the steps are more, but the problem is very easy. These type of problems are not asked in the exam until now. From this main they will ask only 2 marks every time. So if this question is asked in the exam, so they will ask for 3 marks. So until now they are not asked 3 marks from the logarithm. Only one time they are asked for 3 marks, but it is very simple way. So what we doing differentiation here, function to the power of function. This type of differentiation we already done in the 2 marks. So in the 2 marks we are doing only this much of doing differentiation for 2 marks. Double work here we have, so we are doing 2 marks question, 2 problems here. We are taken u and v separately and we are doing differentiation. So 2 marks of 2 problems we are doing. So that's why they will ask for 3 marks. Is it clear? This question will be for 3 marks. Very easy problem. So practice the problems more number of time, then you will get answer definitely. So already we completed the differentiation, just we are revising the concept. In only in the one next video we will complete the revision. So revise the concept as many times as possible. What I done the questions, write down those questions in the white page, in the white sheet, without seeing the notes or my video. So practice in your without seeing any notes, then definitely you will get answer. So practice more number of time. This is the correct time for you people to study the differentiation. If you know the differentiation, all the other chapters will be easy for you people. So in the next chapter the revision will be complete. So from the after the next concept we'll go for the application of derivative. So let me end the revision in the next video. So thanks. So we'll meet in next class. So okay.